Welcome back to this lecture series of multivariate calculus. So in this lecture, I'll talk about implicit function. Okay, so let's understand what is the implicit function. So before understanding the implicit function, we have to know what is the explicit function. Okay, so suppose a function that will be called explicit function, if it can be given or it can be expressed in the terms of the independent variable. So independent variable you can say take as x, and dependent variable y. So take this example. Okay, let's say y equal to x square plus x minus 10. Now here basically x is your independent variable, y is the dependent variable, and x is the independent variable, and we are expressing this dependent variable in the terms of this independent variable, right? So basically left hand side you have your dependent, and right hand side you have the independent. So clearly you can express the dependent in terms of independent variable. So in the case, suppose that dependent and independent together are exist in the case of implicit function. So basically implicit function is given in the both terms of dependent and independent. So in the previous equation, if I write in this way, uh, y minus, so I basically what I did, I taken all the items, all the variables from the right hand side to the left hand side. So it's become the implicit function, right? So in that left hand side, we have both the dependent variable as well as the independent variable. So sometimes basically it is convenient to represent in the implicit way, because it is not easy to represent in the explicit way. Take this example. Suppose we have this equation of the circle x square plus y plus equal to x square, where a is the constant. Then if I want to express in the explicit way, then it should be left hand side should be exactly equal to y some function. Then either it will be y equal to square minus x square, or y equal to negative of s square minus x square, right? So mm, so together, so y has two representation. Now if I want to find out the differentiation of this function y, then which one I should take, this one or this one? So this is the problem. So if I want to find out differentiation of this function with respect to x, right? So that is the one problem. So we have to take the implicit function differentiation. So how to find out the differentiation of the implicit function? By using the partial derivative we can do it. Suppose this function xy, this is the implicit function. Now to find out the differentiation of this function, we can write in this way: del f del x plus del f del y into dx dy equal to 0. Del f del x plus del f del y equal into df dy dx, because y is basically the function of some x, right? So we can find the differences. Now to find out the dy by dx, I can do okay, before that I represent this term as fx suffix x to represent the partial derivative of f with respect to x. Similarly, del f del y, that is the partial differentiation of the f with respect to y. Now dy by dx equal to negative of f x by fy, right? So in this way I can find out the differentiation of the implicit function. Now take one example of this implicit function. Suppose we have this equation: y to the power x plus x to the power y equal to x plus y whole to the power x plus y, and we have to find out what is the dy by dx. What is the dy dx? So in that, to find out this thing, I have to differentiate this one, and it will be very difficult, right, to find out the dy. But by using the this previous formula, that is negative of fx fy, I can easily find out. So I have to find out the partial derivative of this function with respect to x. So I am taking this considering this function by taking this right hand term in the left hand side. So fxy equal to this one. Now after that I'll find out the partial derivative of this term in this way. So it will be del f del y and y to the power x and log y, because we are finding out with respect to x the differentiation of this function, that will be this one, and then the differentiation of this with respect to x. So y is constant, so n into n x to the n minus 1, so y into x to the power n y minus 1 and so on. And here also we can do the differentiation in this way, so we can find out dy by dx. Similarly df dy we can find out in this way. So ultimately I can find out dy dx as equal to this one, that is partial derivative of f with respect to x and partial derivative of f with respect to y, and ultimately I get this result. Okay, so that is the one application of the implicit function of this problem. Okay, thank you. See you in the next lecture.